Hello everyone. So we are we'll be solving our median of two sorted arrays problem in big O of log of mean of m and n time. So let me open Leetcode. So I am already solving questions beforehand to be prepared for before like giving live sessions, so that I'll be able to explain what I am solving. Yeah, and also let me open the app eraser.io. So our problem was as we have seen in brute force merge method, like we will be given two sorted arrays, nums1 and nums2, of size m and n respectively, and we have to return the median of two sorted arrays, and the overall runtime complexity would be big O of log of m plus n time. So this time complexity makes our problem hard. So if we will be using like the approach we'll be using to solve this problem is partition of the arrays, like on the sorter array, and doing binary search, a modified binary search. So yeah, let's go through the solution and try to understand. So to solve the median of two sorted arrays problem in big O of log of mean of m or n time. So this is why our problem is hard, because we have to solve in this time complexity. So we use a binary search approach rather than the brute force merge method, and I have already created one live session for this one. So let's see the problem statement. So we will be given two sorted arrays. Let the sorted arrays input will be nums1 and nums2 as given in Leetcode, nums1 and nums2. So, and we have to find the median of the combined sorted array, where m and n are the length of the arrays. So m will be the length of nums1 array and n will be the length of nums2 array. So we have to write some so it's not that we have compulsory, we can we can assign a variable with name m and assign the length of nums1 onto the variable, and similarly for n we can assign the length of nums2. So I have just to explain this, I'm using app eraser, and I have taken one example, and we'll be solving one or two examples which is not also included in this one. So yeah, fine. So what is the key insight before solving this problem? It's saying instead of merging, so we'll won't be doing merging, we partition the arrays. So we have two arrays, so we'll partition both arrays such that left half and right half together contains all elements. So if we have one array, so if we partition, then it will be like left half and right half of this particular array. Let me rejoin this one. Similarly, if we partition this one, like this to be select and partition, so this will left half and right half. So what do we mean by partition is like left half and right half after doing partition of the particular array. So we will be doing partition on both arrays such that left half and right half together contain all elements. So like the number of elements is not going to reduce, so total number of elements in both the list is 3 and 4, 7. So why we are doing partitioning is we will have such a partition where onto the left of this partition every element will be smaller than the right partition. So what are the numbers in our left partition? 1, 3, 8 and 7, 9, 10. So like I am giving you example of solved problem for solved partition. So what will be the left half elements after this is partitioned? 1, 3 and 7, and here it will be 8, 9, 10 and 11. So this will be the left half and right half. So the after the partition, like 8 will be this in the right half and 7 will be in the left half. So this left half is less than all the elements in the right half. So how this partition will be going will be taking place, we'll go through the algorithm steps, then we'll come to know. So let me rejoin. So I hope I am able to understand, like we need to partition the combined array in such a way that there would be some point where the left half elements will be, actually 8 will be also be in the left half, sorry. So left half will contain one more than the right half. So in case there are odd numbers of elements in the combined array, so when suppose we are combining all the elements, so if you place all the sorted elements side by side, what is that? 1, 3, 7, 8, 9, 10 and 11. So this will be the sorted combination. So actual array is like 8 is here and 7 is here. So our actual original arrays that for this example I have given, like I have taken one example where it is 1, 3, 8, 7, 9, 10, 11. So this is our array. So when there are odd numbers of elements, then the left half will contain, I am giving you the final, we'll explain how it comes first beforehand I am explaining. So the left half will contain one more than the right half when there are like odd number of elements. When there will be even, suppose 8 was not there, then somehow partition will be happening and there will be only 3, left half and right half will contain equal number of elements. So I hope I am able to understand what will be the why we are doing partitioning. So partitioning is to partition the combined array in such a way that after partition the left half may contain one or equal number of elements to the right half, and the median if there is their odd length, so this one is odd length, so the median will be the, since left half contains one more element, so median will be this 8. So if 8 was not there, suppose, then there will be like, we need to have equal number of elements to the left and right half. So partition will be here. So we'll take the average of these two, left of the partition, right of the partition, and average will be 9 plus 7 by 2 is like 8. So median will be 8. So I hope I am able to understand why we are doing partitioning. So median is like the middle of the element. When the array is sorted, the median is like the middle position of the combined array. So we are partitioning our combined array in such a way there is two partitions, left half and right half, and the left half contains all elements less than equal to right half elements. So let us go through the algorithm steps. Where is explaining this problem is difficult than solving actually, once we understand. So let me copy this one. Sorry. This is your first array. So let us give us, but before applying this algorithm, one thing we need to keep in mind, like it's a necessary step. We perform binary search on the sorter array. So I told you there is some binary search algorithm, modified binary search, not the usual binary search we actually perform. We perform binary search on the sorter array. So suppose in another example there might be like this one, the 7 9 would not be there. So the binary search first array will it will be the second array and it will be the first array. So binary search is always on the our algorithm will do the binary search on the sorter array. Please remember this one. So let me do Control G to get back to the original. So this is our two arrays, nums1 and nums2. So let us rename this. So to first and second. So we'll reassign the references. We'll create a reference or copy of the we'll create one reference to the first to the sorter array, and second in our when we will be solving in like algorithm like in code, we'll create one more two variables, first and second, and first will be pointing to the length array, means referencing the array with shorter length, and second will reference the array with larger length. Now the partition logic is so we'll have we want to find an index I. We have to find the partitions in both arrays such that I will be the partition of A and J will be the partition of B, and we are solving a median problem, no? So as I told you, when there is an even length, so suppose there is a 3 plus 4 is 7, and like this means to have the odd length included, like so half is calculated as length of first array, second array plus 1 by 2. So this is the way half is calculated to balance the odd case. Like if there is like for this algorithm, like to just balance out the steps to calculate the half, there is one more added, not just the m and n. So just keep in mind. So this algorithm is being solved for many years. So the better approach is always add 1 to calculate the half. So median is what? Like we have to have equal number of elements to the left and the right of the combined sorted array. So our combined sorted array for this one will be, let me write it here. First one will be 8, first one will be 1, then second 3, third 7, fourth 8, fifth 9, 6th 10th, and 7th 11. So this one will be the combined array. So the partition will be this here, this position. So left will always contain one more in case of odd number of elements, and suppose it was not there, so let me just copy this one. So if there are even number of elements, then there will be equal number of elements to the partition, I'm just giving partition for visual representation. Always like it's not like there is some index here. Please remember, like when I was also learning, then I used to get confused with this partitioning visual representations. Why they are doing partition? Is there some index or what? So this is not an index. Index is 0, 1, 2, 3, 4, 5. This is the index only. So please remember, just for visual representation I'm given, like there is some partition where there is equal number of elements to the left and right, and in odd there will be like one more in the left side than the right side. So we have to like, if according to our algorithm we have two pointers I and j partitioning A and B array, first and second array, and I is calculated at I is the cut in and j is the m plus like as I told you, half is calculated as this one, and j will be suppose I is 0, so j will contain all the elements in the right side. There will be no elements deducted from the right side. So we'll get to know why we are doing this one. And there is a condition, like how we find partition is, we have to find the correct partition such that all the elements of left in the first array is less than all elements of B, means partitioned right in the second array, and all the elements in B left is less than partition of the first elements right. So what do we mean by this one is like, let me go through this one. So when we'll be solving this algorithm, so there would be some point. So like, let me guess, before giving me the final solution, let me just delete this one and let's create two pointers. This one is I, and this one is j. I want to rename this like this one. J, yeah. So we have like I told you, there is some condition. So what do we mean by this condition is like, this is the partition condition. So suppose here is I, so all the elements from the I index going to from I to this is right, and from I to this side is left. So this one along with all the elements to the right is right of the partition, and this one not including I, means from I minus 1 is the left side. Similarly for the j, all the elements from j going to this side is the right half of the partition and this one is left side. So we have to find such a partitioning point for I and j such that a left is less than equal to b right and b left is less than equal to a right. So suppose there is some partition, it's not I'm giving correct, so this one is right and this one is left, and similarly here is partition, so this one this side is right, this side is left. So we have these two partitions. I minus 1 is left side and j minus 1 is the left side of second, I minus 1 is the left side of first. So we have to find whether every left, so trick to remember the condition is check the diagonals. Means if we want to remember how it is compared, just like there are two partitions both, so it just from the partitioning point just remember, like we have to compare this one and this one. So we have, this arrow is not working correctly, so we compare left this one with this one and this one with this one. So this is the partitioning condition. If both are correct, a left is less than b right, in this case is correct, 1 is less than 9, b left is less than a right, it's not correct. So our second condition is not satisfied in this from the partitioning condition. So what do we understand by this? So let's go to our algorithm. So if a left is greater than b right, a left is not less than means if is not true, like in this case our condition is true, a left is less than equal to b right, this is a left, first left and first right, second left and second right. So our first condition is true and second condition is b left is greater than equal to a right. Yeah, here the b left is greater than a right. So our condition is violated, b left is not less than a right. So what we need to do is, like if the first condition is violated, we have to decrement the high, and if the second condition is violated, we have to increment the low. So let's go to our algorithm example diagram. So our first condition is not violated, we don't have to decrement the high. So how this I and j is calculated, let me keep the, so I is first calculated is low plus high, low plus high by 2. This is how I is calculated. So like I told you, there is a calculation for half, m plus n plus 1 by 2. Like median partition will have equal number of elements on the left and right side. So in this case, from visual also there is not equal number of elements, like here it is 1 2 3 4 5 elements to the right and only 2 elements to the left. So if our second condition is violated, like from the algorithm, just don't consider like when we'll from this example, it will seem that we are moving only one step. like we are not moving I and j, we are incrementing low and decrementing high in the condition of violation. So this algorithm is such that we are have to increment low when the second condition is violated, and we have to decrement the high when the first condition is violated. Why? Because to keep the equal number of elements. But just don't consider that we are in like maybe like I would be calculated such that I will directly come to here instead of only one step. In our example, it will be like seem like it will be moving only one step. So I is this one, and j will be half minus I. So I and j both partitions means including them should have equal number of partitions, so we are subtracting I from half. So I hope you are getting me. Left half will contain half elements, right half will contain half elements, and j will have left half will contain one more, plus 1 here it is there, so left half will contain one more. So to get equal number of elements from the I, left of I partition and j of partition, and right of I and j, this is the means j and I and j are calculated. So our I in this case is low. So what is low and high first? Yeah, so low will be, like I told you, we'll always do the binary search on the sorter array. So the low will be the starting index 0, and high will be length of the array, means the first array. So high is 3. So it is index out of bounds, like actually the indexing starts in array from 0, 1 and 2. So here's max index if we are doing is 0, 1 and 2, but to calculate I we have to use the high as length of the first array. So 0 plus 3 by 2, zero plus 3 completely divided by so it should come as 1, and j will be half is m plus n by 2 is like 3 plus 4 plus 1 by 2 is equal to 4. So our j will be 4 minus 1 is equal to 3. So I is starting at 1 is correct. So I didn't took the when I was explaining, I didn't give the correct example. Let me delete this one. So j would start at the third index. So j will be at here. So as I told you, like partition, this one will be here. This one will be I minus 1. This one will be j minus 1. So our I is 1 and j is 0, 1, 2 and 3. Since indexing starts at 0, so every array, like this one is 0th index, this one is 1, this one is at 2th index, this one is at 3rd index, and this one is what does happen, 0, this one is first index, this one is second index. So I came as 1, so I have kept I here, and j came as 3, so j is this. So the right is the right half, means j including this one is right half, and this one is left half of the second array, means left is B, make it as B, or name it as second. Everything is fine. Just for to avoid the confusion, let it be B, let it be A. So this one is the right half of B and this one is the left half, and from here this one is the right half and this one is the left half, and this I'm just giving as a representation of partitioning point. So we have to check whether the A left will be always I minus 1 and B right will be I, A right will be I, sorry, A left I minus 1, A right will be I, B left will be J minus 1 and B right will be J. So we have to diagonally compare. I showed you the trick to remember this condition is we have to compare this diagonally, and this one. So if we will compare this diagonally. So is A left less than equal to B right? Because here this is the condition. A left less than equal to B left. I minus 1 is A left. Yeah, is correct. And B left is less than equal to A right? No. So this condition is violated. B left is not less than equal to A right. So what is the, if condition is violated, means B left is greater than A right. So we'll increment our low by 1, I plus 1. So what was I? Low. So I don't take the previous value. I will be incremented from the low and high. Low and high are incremented, not I and J are not incremented. I and J are calculated. Calculation is based on low and high. So low will be I plus 1. So low is current I is 1. So previous low was 0. Now current low is 0 plus 1. That is here instead of 0 it will be 1, and high is already 3. So 4 by 2 is 2. And J will be 4 half minus I. I is 2. So J will be 2. So where is our I? Here. I will be at 2. So partition will be here. And J will be at 2. So currently J is at 3. So J minus 1 will be at 1. So here is a virtual partition representation of the partition. Now check the condition. J is at 2, I is at 2. Yes. A left is less than equal to B right. 3 is less than equal to 10. It's correct. And B left is less than equal to 8. No, not correct. 9 is not less than 8. So again we'll have to reapply our this algorithm. I will be low plus high by 2. So we have to increment the low as I plus 1, current I plus 1. So current I is 2. So our low will be 2 plus 3. 2 plus 3 by 2 will be 5 by 2 is low plus 1 is, sorry, low is 2, 3, it will be low plus 1 will be 3 plus 3 by 2, it will be 6, it will be 3, sorry, and 4 minus 3 will be 1. So I will move to 3, just like this is index out of bounds. Yeah, for this particular example we have to consider that if the index I and j are out of bounds, like so if I here it came as more than the current index, like index is like 0, 1 and 2, so just consider it as positive infinity, because this is sorted array. Remember, we are given sorted array. So this will be all, suppose there will be more elements in there, it will be always be greater than 8, because first both itself are sorted. So here it will be negative infinity. Just consider, according to the programming language, you will have to implement the infinity based on the programming language. Like this is actually the keyword in JavaScript for infinity. So for Python is float of positive and minus infinity. And I became 3 and j was 1. So j would be 1. So j minus 1 will be 0. So this will be the virtual partition. So now check the condition. A left is less than 8 is less than 8 is less than or equal to 9. Yes, correct. Let me just move it for 8 is less than equal to 9. 8 and 9. Yes, correct. 7 is less than infinity. Positive. This one is positive. Yeah, is correct. So now both our conditions are satisfied. So when both conditions are satisfied, so we are our partition condition is correct. So as soon as we can have this condition satisfied, we can calculate our median. So to calculate the median, there is a formula, and formula why it is I am explaining you. Yeah, so this is the it's not getting copied. If total length is even, then the median will be max of a left or b left, or mean of plus mean of a right b right by 2. So I told you, like when there is an even length, here in this case I showed you, like when there is an even length here, so the median will be median. How will you calculate this? So when there is an even length, we'll take the left of the partition and right of the partition and calculate their average. So it will be like, so suppose 8 was not there and this was an even length like array, like combined array, then it will be like average of 7 and 9. So there would be some functions to calculate the average, and it will average of 7 and 9. But our case, there is an even odd number of elements. This is not true for our case. So we'll take the left will always contain one more than the right, as I told you, because of how way we are calculating half. So it will be the max of median. 8 comes between the 8 has equal number of elements to the left and right. So 8 is the median element. So this is the reason we have this like for median calculation formula. So how what is like median is max of, so left contains all the elements in the left contains lesser value elements than the right. So the median will be suppose I am telling you, so when you are calculating median, so let's keep these two elements together. So this 7 is left half of the second element, and all these are left of the first, and right has infinity. So we'll when we are calculating even length, we'll take the max of a left and b left. So which one is greater, because 8 will come after 7. So it's like left half contains all the elements that are lesser than the right half. So either the left of this one or this one, both can be the max. Before this left and before this left, all elements will, like before 8 all elements are less than the 8, and suppose 7 had more elements here, then it would have been less than 7. So we'll only compare the max of a left or b left. We just need to compare the left side when in case of odd number of elements, which one is max, and it will be our median. For like the median of even length elements, there is like we have to take the maximum from this side, left side, and the minimum from this right side. So when we are calculating even length, like what is the formula for even length? Maximum from the left side and minimum from the right side, and take their average. So we have to take the maximum from the left side, minimum from the right side, and we have to take the average. So this is where the median is calculated. So I hope I have been able to explain you the steps to calculate this median using this algorithm. Now let's try to solve the problem in Leetcode. I have solved this one. Maybe I hope I will be able to solve this again. So first is like we have to compare the length. So let's calculate the length of nums1 and not just compare before. First is equal to, so as I told you, just for our convenience, we are using first and second, or A or B, whatever you can give. Let it be A, let it be B. So if length of nums1 is less than length of nums2, a is equal to nums1, else and b is equal to nums2 less than equal to, and if length of nums1 is greater than nums2, then our left will be means a will assign as nums2. So we'll do binary search on the sorter array. B is equal to nums1. So if length of nums1 is less than length of nums2, so where it is, we perform binary search on the sorter array and see the second array's length and ensuring m is always less than n. So let's take m as length of a and n as length of b. So I have already assigned the sorter as a and larger as b, nums1 and nums2. Now we have to do our partition logic, I and j and all. So let's write a method binary search that takes the two arrays a, b, m, n. It takes the two arrays, first and a and b, a shorter and larger length, and length of those two arrays. So median will be, we'll do a binary search, self done binary search, pass this a, b, m and n. So when we are creating an instance, this is a class and we are creating an instance method, then we have to pass the self as the first argument in the method, and we have to return the median also. For the code readability, I am just doing this one. So self.binary search a, b, m and n. Yeah, fine. Then what is the algorithm? So we have our half as m plus n plus 1 by 2 low will be 0, high will be m. High is the length of the first array and low is the starting index. So I is low plus high by 2 Let me check if I'm doing correctly. So we'll come to this one. How will we using this one? So in our binary search, we are having low is 0, high is m. So while this condition is true, while low is less than equal to high, so until our low and high cross each other, or the we'll keep on doing the iteration. I is low plus high by 2, and j is m half minus I. J is m plus n plus 1 by 2 minus I. So this one should be here. I is low plus high by 2. J is half minus I. Yeah, we have to compare a left. Let's initialize everything. It can be -1 also, but let me check if we can use the positive negative numbers for assignment. Nums1 length m, nums1 I can be negative also. A left so I'm getting a call. Let me receive this. Hello. Yeah, who's this? Yeah, speaking. Yeah. I have don't have experience with Ruby, but I have other experience. I have experience in Python and Java and JavaScript. Seven years, 9 months to be exact. Yeah. Current and expected is 10 and 10, because I'm not working for 2.5 years. Because I am not getting selected. By somehow I'm not getting able to clear the interviews. Yeah. 16th February 2023. Yeah, it's updated. 5 years around. Oh, Python also same. 2018 since I am working. 2015, since 2015 I am working. Yeah. 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 Yeah, fine. Yeah, fine. Yeah, fine. Yeah. Yeah. Yeah, thanks. So let's continue. So we will be calculating our binary search, like this is for this particular question only, binary search method. So we have taken our I and j, check if partition is valid. So what was our condition for partition? This one, a left is less than equal to b right, and b left is less than equal to a right. For this we have to take this a left, a right, b left, b right. So let me just copy for the sake of simplicity. So let's go back to our, so what I told you, j I will be a left, I minus 1 will be I will be a right, and I minus 1 and left will be left. J will be right and j minus 1 will be left. So a left is a minus 1, condition is already given. A right is ai if I less than m, else infinity. B left is bj minus 1 if j greater than 0, else infinity. So in Python we can write this syntax. To assign a value, we can, like, if I greater than 0, then we have a valid index, because I can be max of 1. 1 minus 1 will be, means it will be within the bounds of our array. Else, but yeah, to assign infinity is we have to use this method, float minus some like, and a right is ai, I and all elements to the I plus 1, I plus 2 will be a right. If I is less than, else infinity. Why is we are taking infinity? I've already told you from the example that both are sorted arrays. Here it will be negative infinity and here it will be positive infinity. Same here also. Negative and positive infinity. B left will be bj minus 1 if j greater than 0, else negative infinity. B right is bj if j is less than n, else infinity. So let's have this I and we'll check later whether I and j are required or so we'll have our part. We have this a left, a right, b left, b right according to our diagram. J means from this diagram I showed you. So let me copy this condition. We found the correct partition, like in our search step we have to check if the partition is valid. So when is the partition valid? When this condition is satisfied. So whether we have to check whether partition is valid. If a left is less than equal to b right and b left is equal to a, then our partition is valid. So let's reassign to a variable, is partition valid. and this one, and instead of having it directly here, we can use this condition, if each partition. So in Python there is concept of truthy and falsy value. So we don't have to write like if pi is equal to true. So it's like this will return either true or false. So we just by having if true, so we'll get if each partition is valid, then what was the step? We have to calculate the median. So partition is valid means we can calculate our median. So this is the then if total length is even, so median is equal to total length is even means if partition first is like if partition is valid, then is if total length is even. So if m plus n is the total length, mod 2 is equal to 0. Even means when we divide the length by mod 2, it will be like mod 2 is equal to 0. So median will be max of a left and so as I told you, it will be the maximum element from the left side and the minimum elements from the right side, and we have to divide by 2 when the length of the combined array is even, else it is an odd length element. If not even, then it will be odd only. So in maths we can either have odd or even. So then we can just return the maximum from the left side, because left will contain one more elements. As I told you, left will always contain one more element if in case of odd number of combined elements. So yeah, this one is correct. I am giving 0.0 to have float division, and we can return the median, and here also we can return the median. Let's test our code. Invalid in syntax. Oh, this one. Yeah, we are missing our crux of the algorithm. Where it is, very good. So if the first condition is not valid, we have to decrement high, and if the second condition is not satisfied, means if its opposite b left is greater than a right, then we have to increment the low. So instead of writing this way, we will use this approach. Else if a left, so if a left, this is our first condition, is not valid, if a left is greater than b right, means if not less than equal to, then what it will be? It will be greater than b right. So this is our first condition violation, and the second condition violation is in Python it's elif, and third will be like this one only, elif b left is greater than a right. So first condition violated means we have to decrement the high, second condition violated we have to increment the low. So in essence it means moving left and moving right. So when we were solving this one, so first condition violated means a left is not less than equal to right. So we were moving left, we were in the this one, and a second condition we were moving right in this way. So opposite is like getting moved. I hope I am saying correct. If not, just correct me. Low plus 1, elif high is equal to I minus 1, sorry. Low is equal to I plus 1. So we will have to increment high based on the ith value. Since we are doing binary search on A, so we have to use this I plus 1 and minus 1 on the condition by being violated. So let's test this one. Indent doesn't match. No. So our solution is accepted for these two test cases. Let's submit, and then yeah, solution is accepted for all test cases. So I hope I am able to explain. Like this part is like algorithmic way. Like this algorithm has been developed such way. Like you have to move left and right. Like this low I plus 1 signifies moving to the right, and high minus 1 is signifying moving to the left of the partition. Means this one and this one. This is the left and moving. Like in the combined array, this is the approach, like how this algorithm has been devised, moving left and right in the combined array. So if you want to dive deep, try to find out how this is like being implemented. Yeah, so I hope I am able to explain it, and we have solved this one. Like we'll solve again the next question in the upcoming live session. Thanks a lot. I hope I am able to somehow explain. This was a very hard problem to solve. So yeah, and more difficult to explain actually. Yeah, thanks. We'll meet again in the next live session.